Alright, so continuing on from where the problem left off, we have the same right hexagonal prism, the base sides of 4 and a height of 8. Now it wants us to find the volume. Well, in the previous part, we found out that the area of the base was 24 times the square root of 3. And the volume is just the base of the object times the height of the object, or the area of the base times the height of the object. So all we have to do is take the area of the base, 24, times the square root of 3, and then multiply it by the height, which is 8. And that condenses down to 192 times the square root of 3. So that is it for part A. This is mostly based on the previous work we had done in the last video. Now let's look at part D. Find A, B prime, A, C prime, A, D prime. Well, let's note that A to B prime is the diagonal line from A to B prime on the rectangular surface. Now, this rectangle has the dimensions of 8 and 4. Now we can just construct, like I usually like to do, construct this rectangle separate from the three-dimensional figure because it helps me kind of visualize what's going on. So we have A prime, B prime, B, then A. And A to A prime has a length of 8, AB is a length of 4. Now I am interested in finding A to B prime, the diagonal. We should note that we have a right triangle with dimensions of 4 and 8. So if we use Pythagorean theorem, we have that 4 squared plus 8 squared is equal to A, B prime squared. Now we have that's 16 plus 64 equals A, B prime squared. Combining these together, we have that this is equal to 80. And if we want to reduce that by taking the square root on both sides, we have the square root of 80. Well, 80 is 8 times 10, so it's the square root of 8 times the square root of 10 equals A, B prime. 8 is 4, and square root of 4 times square root of 2 times, well, we have 10, which is the square root of 2 times the square root of 5. The square root of 4 reduces to 2. The square root of 2 times square root of 2 also reduces to 2, and we're left with just the square root of 5 equals A, B prime. And that gets us 2 times 2 is 4 times the square root of 5 equals A, B prime. Okay, so we have solved that part. Now let's look at the next one. We have that we want to solve for A to C prime. Well, that would be the length from A all the way to C prime itself. Now that can be a little bit harder to visualize, but what we could do is we can connect A to C, and then if we look at the figure C prime A C, that is going to form a right triangle because it's a right rectangular prism. So that means that the angle right here is a right angle. So let's reconstruct this problem. Let's cut off the rest of the work as a triangle problem. So I'm going to draw out the triangle. And let's label the points appropriately. We have A to C, then our right angle, and then we have C prime. Well, we know what C prime to C is. That must be 8 since it's the height. And we want to know what AC is. Well, let's think about the fact that what kind of shapes are we working with? Well, AC would be a part of the rectangle A prime, C prime, C, A. So I'll highlight that triangle, or that rectangle, sorry, as so. And if we can find out the distance from A prime to C prime, we could figure out, well, the distance from A to C. Now, is there any reasonable way we could approach that? Well, we have, again, that C prime is 8. And maybe we could make a triangle out of this. Now, let's look at triangle. Well, looking at these dimensions, it's hard to really know how to approach it. So let's see if we can make AC a part of another triangle, not the one we already have. How about by connecting it with D? So I'll do that in a different color. We're going to have A, C, D. Now, why would I possibly pick that as my triangle? Well, what I know about hexagons is that we can find the total interior measure of the angles by taking, in any polygon, the number of sides, so there's 6 sides in a hexagon, subtract that with 2, multiply that with 180, and divide by the number of sides again. So, this all just comes from when we did our work on polygons. So if you need to remember this formula again, just refer to that chapter. 6 minus 2 is 4. 4 over 6 becomes 2 over 3, multiplied by 180 is going to become, well, if we think about 18 divided by 3 is 6, times 2 is 12, that would be 120. So this entire interior angle is 120 degrees. But notice that AD is the diagonal across half of the hexagon. And because of that, it's actually cutting this angle here, the smaller portion, in half. So that's a 60-degree angle. And we know that from here to here must be 90 degrees, so we actually have a 30, 60, 90 triangle. Now that can be a little tough to see, but again, this is all just information we have learned about in the past. So the fact that we have a 30, 60, 90 triangle, where the smallest side, the one opposite to CD, is 4, that means that AC, the side across from the 60-degree angle, is going to be 4 times the square root of 3. which gives us our length of the triangle here. Now, going back to the original diagram, we have that, there you can use Pythagorean theorem, AC prime squared is equal to 8 squared plus 4 times the square root of 3 squared. So, reducing that, we have AC prime equals 64 plus, well, 4 squared is 16 times the square root of 3 squared, which is 3. 16 times 3 is the same thing as, what am I doing? 16 times 3 is 30 and 18, so 48. And combining these together, AC prime squared, I should have put, well, 60 and 40 is 100, and 4 and 8 is 12, so we have 112, which means that AC prime is equal to the square root of 112. Now, the square root of 112 is the same thing as 16 times 7, which can then be broken down. AC prime is equal to, the square root of 16 is 4, then the square root of 7. So that gives us, let's see, that's a genuinely tough problem, but we still have another part to go. We want to find now A to D prime. Oof. So let's clear off some of the space that we've worked with over here. This is definitely one of the more complex problems we've worked with. Okay. Now, A to D prime. So, connecting that, that would be the space diagonal of this hexagonal prism. How could we possibly find that? Well, again, if we just use the knowledge we know, let's try to make a right triangle out of this. Let's connect A to D. And then let's try to figure out if we know some of the dimensions. Well, we have that this is 8. So what could AD be? Well, AD is just, if we think about it, this comes from when we did the previous parts, A and B. A hexagon is a series of equilateral triangles put together. Now, each of these equilateral triangles has the same side, 4, which means that this length is 4 and this length is 4. So that means the entire length of AD is in fact 8, which means, considering this is a right angle, we have a 45, 45, 90 triangle where AD prime is equal to the side length of 8 times the square root of 2. Oof. So that completes the problem. Now, yes, that is a very tough problem, but just take your time, break down each of these things into different objects that we know about. Triangles, rectangles are the essentials. They're the easiest shapes to work with. Each of these 3D shapes is just a series of similar 2D problems. Take your time and Even if you mess up once or twice, that's fine. Just try out as many ideas as you can. Try to visualize it in the 3D space, and hopefully you'll come across the right answer.